Now that we've covered the spatial elements within the IFC export, such as the IFC spaces and IFC zones, we'll now look at actual building elements. Unfortunately, Revit's inbuilt categories do not align to the IFC classes for building elements, nor can they be amended, added to, or deleted. The object styles defines the list of categories for Revit model objects. Therefore, in order to export to the correct IFC class, Revit allows for the default setup for what IFC classes Revit categories get exported as. If I go to File, Export, and scroll to the bottom, and under Options, select IFC Options. Here I can define the IFC class name that particular Revit categories are exported as. I can also set particular elements to be not exported. For example, areas can be exported as IFC space, and ceilings are to be exported as IFC covering. Note that it's always worth checking the correct categories or IFC class names that will be exported as for example, plumbing fixtures will be exported as IFC flow terminal. However, reviewing the inheritance listings for IFC4, notice that flow terminal has subclasses underneath, and there is a subclass called IFC sanitary terminal, which when selected I can see is a new entity in IFC4 and is a fixed appliance or terminal usually supplied with water and used for drinking, cleaning or foul water disposal. So I'm going to update the plumbing fixtures to export as the IFC sanitary terminal class by default. So it's always worth checking that the export settings are updated to suit the version of IFC that you are implementing for the model exchanges. It's possible to save as and load additional text files to share these settings within your organization or project. If I select an element in DDS CAD, for example this floor here, I can see that it is classed as an IFC slab, although I've only modeled it as a finish for this particular project, which is a 50mm travertine tile. If I go back to the IFC export classes and I scroll down to find floors, I can see that they will always be exported as IFC slab. And under the definition of IFC slab, only the core or constructional part of the slab is considered to be a slab. The upper finish, such as flooring, roofing, and the lower finish are considered to be coverings. Therefore, this finish floor that I've modelled within Revit should in reality be an IFC covering and not an IFC slab. So let's have a look at how to override this within Revit. In order to be able to override the exported class for a particular family or type, there are two project parameters that I need to add to the project. Because I am now going to be looking at the types of elements rather than individual elements, I need to change the shared parameter file to the type shared parameter file. I now need to find the two IFC parameters, IFC export as and IFC export type. The IFC export as parameter defines the IFC class that element should be exported as. I will set this as a type parameter under the IFC parameters group, and for the time being I will just associate it to the floors category for the purposes of demonstrating this functionality. I'm also going to add the IFC export type parameter, which allows me to override the predefined type enumeration value for that IFC entity. If I now select this floor and select Edit Type, I now have the two parameters in the type properties here. So I can now specify the type of element that I wish to export this floor as. So I'm going to type in IFC covering type, and in the export type for IFC coverings, I need to specify the IFC covering type enumeration, which defines the particular type of the covering. Because it is a floor, I can type in the word flooring, as this covering is used to represent a flooring. Note that this enumeration defines the range of different types of covering that can further specify an IFC covering or an IFC covering type. So the IFC covering is the individual occurrence of the covering, and the IFC covering type is the type object associated to that individual occurrence. So back in Revit, I can simply type in flooring, click OK, and now when I re-export the model, I can select the floor element and note that the IFC class has been amended to an IFC covering, and the predefined type has been updated to flooring. I can also see the IFC covering type is also the predefined type of flooring, so see how the two are interlinked. I could also do the same to these basic roof chrome finish elements. I have added the IFC export as and IFC export type parameters to the roof category. So here I can type in IFC covering type. However, note that I can also, instead of using the IFC export type parameter, I can instead type a full stop or period and then type in the predefined type that would otherwise go in the IFC export type parameter. Note the full stop or period between the two. I can select OK, and both of these are the same type, therefore the data will be updated. And I can now re-export the model, and if I select the element in the IFC viewer, I can see that both of these roof elements are now the IFC covering with the predefined type as roofing. So note that the two different methods of filling in the IFC class name and predefined type vary within Revit, so you can choose the method that suits you or your organization's workflows the most. Now that we've correctly assigned the class and predefined type to, for example, this floor, which is now an IFC covering, let's take a look at the occurrence and type attributes. Revit, by default, will export the name, object type, tag of the occurrence and the type name tag attributes. It will give it a default name of the family name, so in this case floor, and then the type name, and then the element ID of that particular element. The object type is the same, but without the element ID. And the tag is the Revit element ID, and the tag for the type name is the Revit type element ID. However, the attributes visible here are not very useful when it comes to relating the information to documentation, schedules, or specifications. Therefore, we need to update this information and add additional attributes as required to ensure that the attribute information in the IFC aligns to that produced within the design and construction documentation. If we take a look at the type parameters first, for the project parameters, I'm going to add from the type shared parameter file the IFC name type parameter. Add it as a type parameter under IFC parameters, and I will assign it to floors and roofs for the time being. If I now select on this roof and select Edit Type, note that my type has a code, RF01, which is the type that will appear on my drawings and roof types documentation. It will be specified with the type mark RF01. In order to align this information and export it correctly to the IFC name attribute, I can use the IFC name type parameter. Because it is IFC name type and it is assigned at the type level, it is associated to this type of element. I'll therefore give it a name. I'll call it covering roof, and then the type code. I will do the same for the floor type. The type mark should be FL02, and therefore I will specify this as covering floor FL02. Select OK, and now if I re-export the IFC and I now select the roof, I can see that the type name has been updated to the value specified by the IFC name type parameter. I can also add additional type attributes using additional type parameters from the shared parameter file, such as IFC description type and IFC tag type. The IFC tag is the product number or the EAN code, for example, of the particular type of product. Again, this is an optional parameter that you could specify within Revit. However, I'm just adding the parameter to indicate how to set the value from within Revit. I can do the same to the roof type, like so. And then when I export to IFC, the type attributes have been updated. I now have a description and a tag, and the same for the roof covering type attributes. It's also possible to override the occurrence or instance attributes from inside Revit using a similar strategy. Back inside Revit, I'll go to Project Parameters, and from previous exercises, for example when updating the project information and room properties, I've already added a lot of the instance-based parameters to Revit. So I can simply select the IFC name parameter and assign this to floors and roofs. I can do the same for the IFC description. And the same for the IFC object type. I can also add the instance parameter for IFC tag. I need to change the shared parameter file to the instance parameters. And add the IFC tag parameter. And now when I select this floor, I have the IFC name, IFC tag, IFC object type, and IFC description parameters. It's not very often that you would individually document a particular instance of a floor. This is more likely to be used for individual pieces of, for example, furniture, doors, sanitary appliances, etc. However, for the purposes of this demonstration, I can type in an IFC name. For example, this individual unique instance of this floor will be FL2-001. The description, I could copy and paste the same value from the IFC description. The object type is a tricky one because this is usually only defined at the occurrence level when the predefined type of the element is set to user defined. This was okay for IFC 2x3 when there were not many predefined types for particular entities. However, it's unclear what this should be filled in with by default. I will simply type it in as flooring, but it is used as a high-level classifier. And again, the tag is the particular unique identifier for this particular element. I'll simply fill this in with a numeric sequence. And now when I export to IFC, I can select the floor. Note how the name attribute has been updated to the IFC name parameter, as has the description been added, and the object type and the tag. So that is how to specify and override the IFC class and associated attributes for a couple of system families within Revit. Let's now take a look as to how this could be implemented for loadable families.